Hi, and welcome back. In the last section, we looked at TF-vars and variables and how to inject them into the resource. Now, we're going to expand this model to have a look at a scenario with more than one resource. In a real business, it would be pretty unusual to have just one thing in the cloud, and if you're working for government or blue chip, you might have thousands of instances there, and these instances will have dependencies on each other and need to be spun up in a particular order. We're going to have a look at two different types of dependency. The first is implicit dependencies. If you imagine the instructions, build a house, then paint the door green. Any normal workman would build the house first, then, once it was done and he had a door, he would paint that door green. No one would have to actually say to him, make sure to build the house first so that the door actually exists. He would just know that painting the door would be dependent on first having built the house. The second type of dependency is an explicit one. If you said to that same workman, build two houses, but build one on the left first and then one on the right second, that would be an explicit instruction. You would have to tell the builder, otherwise he couldn't reasonably be expected to know which order he was supposed to build them in. Right, I'm guessing that all seems fairly straightforward, so let's go and have a look at how that would pan out in the Terraform code itself. As always, I'm assuming that most of you are working through these examples section by section. If you're not, don't worry, you can download all of the code in these examples from Lernard on GitHub. So, list what we've got so far, and now, like always, we can copy our section 4 folder and name it section 5. People come to Lernard for the DevOps, but they stay for my amazing naming conventions. Great, now we can see that's there. We're going to need to remove the old state files and Terraform plugins directory that are left over from the section 4 lesson. There, nice and clean. Now let's open up our newly created section 5 folder in Visual Studio Code and get creating some dependencies. First, I'll quickly rename this resource to section 5, then let's create a new resource under this AWS instance. We're going to choose Elastic IP for the resource type, and I'll give it the name section 5 IP. An Elastic IP is AWS's brand name for an additional external IP address that can be spun up and attached to an instance. They can be used for directing web traffic or email or as a means to connect to the server. They're just a general purpose IP address, just as you have attached to your house or any otherwhere that needs external traffic to arrive at it. Let's make some curly brackets for the options. Don't worry too much about this VPC option, as it's not relevant to the discussion on dependencies. I'm adding a count here, which I'll talk a bit more about in a moment, but now the important bit. I'm going to specify which instance the IP address should be attached to. This takes the same format as specifying any other component in Terraform, such as a variable or a resource, in that you specify what it is first, in this case an AWS instance resource, and then you specify the name, and then, if you have one, the property of the thing that you wish to reference. In our case, we want to reference the ID of the instance, as that's what Terraform will use to identify which instance to attach it to. Just briefly, we'll ignore the count.index part, and we're going to come back to that in a minute. So then, we've said here, make an IP address and attach it to the section 5 AWS instance. Just like with painting our door, it can only do that if the section 5 AWS instance actually exists. So this is an example of an implicit dependency. We haven't written anywhere, first wait until section 5 instance exists as such. We've just said, attach it to it, and Terraform will know that to do this, the instance has to exist first. This is a good time to draw attention to the fact that the name section 5 we've used to identify the instance is based on the name we've given it in Terraform after the resource type. In this case, that's section 5. These names aren't the same though as the names which go into AWS, which are defined with var.name using a tag. These are just the internal Terraform names we use to keep track of things. Right, as I promised then, let's quickly talk about count. Take a look at these three things here, where I specify count twice and then reference it in count.index. You remember me saying in the last section that when you only have one of a particular resource, it isn't mandatory to write count equals 1, but that it's best practice to do it anyway? Well, this is why. When you have a count, it is usually because you want to create multiple versions of something. In the case where you do choose to have a count, if you then want to reference that resource somewhere, you would need to specify which of the instances of that resource you meant. So, in the example we're looking at here, if we span up 3 virtual machines in the instance resource, but only 1 elastic IP, then we would need to indicate which of those machines to attach the IP to using a hard-coded index value. Terraform numbers its indices from 0. So, to attach to the first instance, we would specify 0 in the square brackets, to attach to the second instance 1, and the third 2, like so. If we now imagine a case where we spin up exactly as many IPs as there are instances, then it would be a bit unwieldy to have to write a separate declaration for each attachment. Here there would be only 3, but imagine what a hassle it would be if you had thousands of virtual machines. With that in mind, Terraform allows us to write count.index, which will cause the count of each elastic IP to match itself to the instance with the equivalent count, like so. The counts don't have to match. If there are less elastic IPs than there are instances, it will just keep attaching them until it runs out of instances to attach them to. The important take-home from this is that you can hard-code in values for multiple occurrences of a resource, but count.index will let you automate it as a time and effort saver. As I touched on previously, the property ID is the way in which Terraform identifies the instances for attachment. ID and IP are 2 of the most commonly used properties of instances and other resources, so it's worth me drawing attention to them here. Okay, let's go check we've written this correctly and that it works. Now we're on section 5, you're probably an old hand and remember all of this by now, but first we're going to run a Terraform init to download our plugins. Now we're going to run a Terraform plan. As we expected, we can see here it's spinning up our 2 resources, an AWS instance and the elastic IP that will be attached to it. Let's jump back into our Terraform and add a new value to our TF-vars for number, and we're going to add the value 2 in there. As we discussed in the variables section, this will take precedence over the default value, and because we have used the same variable for count in both the instance and elastic IP, hopefully we're going to see it spin up 4 things now. Again, let's confirm that with our Terraform plan. Great! As we predicted, there's 4 to add. Before we actually apply this, let's go back and add one more thing to our Terraform. We've so far just covered an implicit dependency, so let's have a look at an explicit one too. Go back into main.tf. I'm going to create a new resource called AWS S3 bucket. For any of you that are not big users of AWS, a bucket is their term for a bit of cloud storage you can upload files to. It works like a slightly more technical version of Dropbox in terms of its feature set. In fact, I think Dropbox may even be based on S3, though I'm rambling now. I'm choosing a bucket here just randomly as a component that is unrelated to my instance, not because we particularly need a bucket. It's our version of the second house the builder was asked to create in the example at the start. Let's call it section 5 bucket here. I'll give it a name. We'll choose that it's private and can't be seen by random members of the public. And now, finally, the main thing here, we're going to explicitly say that it has a dependency on the AWS instance using depends on. Terraform won't wonder why it does. It doesn't need a reason. It will just take our word for it that we want the bucket to be spun up after the instance. The last thing I'm going to do here is add the name section 5 into TF-vars. As if I remember rightly, we haven't actually specified that anywhere yet, and I don't want to keep typing it in whenever I run Terraform plan. Okay, we're going to check out that this configuration works with another Terraform plan. And there, it's looking good. 5 things to create, so we'll go ahead and create them with a Terraform apply. Nice, it's done it. Let's go and check it out to see if it looks how we think it should. Sure enough, there's our 2 instances. And if we go down here, There we go. We can see our two IPs attached to those instances. And finally, if we browse to S3, here we can see that it's also created the bucket we asked for. Right, I think we've covered dependencies pretty well there. Of course, it'll get more complicated in real deployments when you've got all kinds of things being spun up all over the show, but the principle stays the same. And if you remember about explicit and implicit dependencies and how to deal with counts, you'll have it all sorted. Let's go and Terraform destroy all of our things now so they don't keep billing us. You can really see the power of Terraform destroy rather than just manually deleting stuff once you start spinning up a few more things like this. As we make more and more stuff, it's going to get harder and harder to remember where we've left it all, so something that just goes and cleans up after us is super useful. One last quick bit of code tidying to do. In the section on variables, I mentioned it's good practice not to leave any hard-coded values behind in the source code if you can avoid it, outside of the variables and TF-vars file. With that in mind, let's go back into main and variabilize our new resources we've created. We probably always want the name Lernard on our buckets, so we don't need to variabilize that, as bucket names have to be unique. But let's variabilize the second half of this name. Notice that as I'm working inside quotes, I'm using the $bracket notification we looked at earlier. Let's variabilize this bucket. We'll create bucket ACL in variables too. And also let's give it a default value here. At this point in the course, you officially know more Terraform than I did when I started my first primarily Terraform driven role. And if you've absorbed it all, you could probably drop right now into a Terraform position. With a few late evenings work, you'd be flying in no time. But just like Top Gun, Lernard.com is looking to train the best of the best. So let's add our new code back into Git and then move on to some more Terraform. As always, we'll behave like professional DevOps engineers by doing a git status to check that our work looks right, then a git add, git commit with a sensible message, and then push back to GitHub. Alright, we made it to the end of another section. In the next section, we're going to take a look at outputs and data. Hopefully see you there.